Thank you very much. It's an honour to be presenting to you all today from a Boston perspective. Here we go. So firstly, just to introduce myself. So my name is Amos Ankrah. I've actually been a quarter of a century in the IT industry now. So working on various technical solutions from individual servers all the way up to multi-million-pound technology transformations. So that's what I've been doing since I graduated. I was at King's College in London. My degree was in biochemistry and pharmacology. And there's me in my graduation photo. And my wife was saying yesterday, Amos, did you really wear that tie when you graduated? But I think it's quite retro now, isn't it? So Boston. So I've worked in IT for 25 years now. So to be able to combine technology and biomedical science, it's a dream come true for me. It's absolutely amazing. Okay, so we're going to cover three main points in this presentation today. So firstly, an introduction to myself and to Boston. We're going to run through a case study which covers the application of the anomaly detection in dense organs. So we're going to run through a case study and how we're using our knowledge to deploy AI within healthcare. And then to finish off with, we're just going to talk in more detail about how we set up that sort of framework. Okay, so you know about me. So Boston is a technology distributor centered around Supermicro as a technology provider. We're 30 years old, so we've been in the industry for a long time now. And our birthday's in December, so expect to see a lot of activity on social media, advertising, all that. So as I said, we centralize on Supermicro, so that's our partner of choice. But what we found is that over the years, there's only a certain amount you can do with a physical server. So we've built out many relationships with many organizations to augment the Supermicro technology. What we found as well is we specialize within the area of high-performance compute clustering, because many organizations look to drive as much value for money as possible in their solutions, and they choose Supermicro for that. And also off the back of that, Boston were the first company to bring the GPU to the UK market. What that means as well is that we've grown, so as a 30-year-old company, as well as being able to stage Supermicro hardware within our deployment plant, we also have Boston Labs, where we've got about £2 million worth of equipment that we work with customers on to test their various use cases. And we've also got Boston Technology Consulting. So this is where organizations know to come to us to talk about AI. And what we've been finding is that there are many organizations that may be enterprise-based rather than HPC-based, and they're making a decision now, do we invest in HPC architecture, or do we add to our existing enterprise technologies? So we at Boston, with our Boston Technology Consulting, we can do the full study and tell you what's best for your organization. We've also got the Boston Training Academy as well. So the Boston Training Academy focuses on training organizations, universities, public institutions on AI. So that's something else that we can talk to you about as well. What I did not mention is that we have a stand. So we're on stand 221. So yeah, please come over, have a conversation, and we'll take your details down. So being 30 years old, we're a global organization. So we've got presence in many locations throughout the world. So we're a big organization. So our main head office, so we're Boston, but we're based in St Albans, about 10 miles or so from here in the UK. But yeah, we've got presence in every continent except South America. Okay, so I talked before about our technological alliances as well. So we've got many alliances which have built up over the years. Something I'd like to call out today, if you come and visit our stand. So we've got Intel Habana equipment on our stand, so low cost acceleration technologies. I believe that we've got a Supermicro box. It's the only unit within EMEA to demonstrate Habana. So please come and take a look at it. We have Pavilion storage technology as well, which forms the storage component of one of the technology stacks that we sell. So high performance, sub-microsecond latency, bare metal performance. So another partner I'd like to call out as well, another complementary technology is a company called Zutacore. So this is two-phase liquid cooling, very handy in terms of energy costs and bringing down those energy costs in terms of cooling the CPUs on your infrastructure. Okay, so we move on to part two. So this is the case study, and so Boston. I work for a part of Boston called Boston Medical, and we're working on AI frameworks to support healthcare, anomaly detection in large organs. And that revolves around cancer. So 10 million people are going to die of cancer this year worldwide. In the UK, the current statistic is 1 in 3 people in their lifetime are going to be diagnosed with cancer, and that's rapidly rising to 1 in 2. So it's a serious business. The majority of cancers as well are typically in large organs in the body. And the thing is, when cancer is detected as quickly, you have the best chance of eradicating the cancer. So quick detection is urgent. Okay? So at Boston, we aim to develop state-of-the-art imaging and IT solutions that will enable better tumor detection and characterization to assist clinicians with the choice of targeted therapy. So why are we doing this? Why are we focusing on cancer? So at the moment, you have your cancer experts and your specialists. It takes time to train up to be an expert in dense organ cancer detection. There's lack of reliability in terms of the information points out there, and it takes time as well. And that's made even more prevalent in terms of COVID. So there are many health services across the world which are suffering with backlogs of cancer diagnosis. So yeah, I mean, it's an evolutionary technology. So by applying our solution, we provide that level of automation. We provide a way of generating reliable results, rapid results, by leveraging the AI engine that we're working on within Boston. So let's run through the scenario. Okay, so you've got your patient who comes in for the CT scan, and so that scan is typically about 25 megs in size, and is then ingested in a DICOM form. So the format's called DICOM, about 25 megs. It's ingested, and then it's correlated against the data that we have within the AI engine. So there are two components to this. So you need to think about storage is so important. So within the AI engine, it has potentially literally millions of scans to compare against the new scan that's coming in. 25 meg files, that correlates to 25 terabytes worth of data. And that's not incorporating things like backup data, historical data that's being manipulated as well for the good of healthcare. New tools that come along as well, which capture images and information in more detail. So you can see quite quickly that 25 terabytes can escalate into the petabyte quite easily and quickly. Okay, so for this, the patient data is collected, it's ingested into the Boston AI engine. So our platform is based on a set of hardware and a set of software called Buddha, which I'll talk about in a few slides to come. So the data is manipulated, and the results are generated based on the data within the AI engine. Okay? So step number 1. So we're focusing on liver tumors here, and it's important that once a scan is taken, we need to identify what is real and what is not real. So which components make up the liver, which make up connectivity tissue, which components make up scar tissue. Also bear in mind as well, there's going to be differentiation between male and female, the age of the candidate, any damage that's been done over time, any disease. So then we annotate the scan. So we talk about the target organ, non-target information, and the tumor. So when we spot the tumor, we talk in terms of the benign tumors, malignant tumors, and any necrotic regions as well. So then we go into the workflow, which has 3 stages. So stage number 1 is to ensure that the DICOM file that we have is of a valid format. So do we need to get that data back again? Can we do what we need to do with the patient's DICOM file? Okay? We then create a 3D image of the liver. Workflow stage 2, we then go through the process of annotation. So we then identify any tumors, any anomalies within the organ. Okay? And then workflow stage 3, we then highlight each individual anomaly and we give it its own identity. This is really important because when a clinician is working with a patient, potentially they're going to be on a medical regime with certain medication. So when we take subsequent scans, we can then track the progress of each individual tumor to evaluate whether the course of medication is working or not. So yeah, at the end, the patient is delivered the results. The patient's given a big thumbs up there, so they're very happy. But ultimately, this makes the process rapid, more accurate, and insightful. And again, remember here, we're not replacing the clinician. We're just increasing the amount of time that it takes for them to make the diagnosis, enable them to make the diagnosis accurately. Okay, so this is the next stage of the presentation. So we're talking about now the AI framework. So this is the hardware and the software that we use to run these AI algorithms. So within Boston, we have a framework in the labs, and it's called Buddha. So it stands for Boston, because we are Boston. U is for unified, because we're unifying the various accelerator components, the storage, the servers, the software, to deliver a technology on a stack. DD is for deep data, because we ingest copious amounts of data for the AI engine then to churn and to deliver its insights. H is heuristic. I love the word heuristic, so our MD loves a complex word, but it's really good because it relates to strategies derived from previous experiences. So all the data are related to those previous experiences. And A is architecture. So some organizations could consume Buddha from Boston as a managed service. Some organizations may standardize on certain technologies, but Buddha is a flexible framework that we can adapt to the customer use case. So in essence, it's all about the data. Data is the new oil. So outside of the medical science division, many organizations are coming to Boston looking to bring their data in order to refine it, in the same way as you refine oil, to charge the customer £2 a litre for their petrol. So there's a degree of exploration, and organizations can potentially have years' worth of data on tape-based backups, but they want to know how can they use that data for the good of their business. So we can work together with the Buddha platform, we extract, we refine, and then we give the customer the insights that they need. This just goes into a bit more detail about the architecture, the infrastructure contained. So AI data governance tools, so we work with the likes of Iguazio, dCube, we work with Kubernetes, TensorFlow, PyTorch. You need a database, MongoDB, SQL. Accelerator technologies, again, come to our stand. Come and reference the Intel architecture that we have on display. Servers, so we standardize on Supermicro. Networking, again, another important part of the topology for users to connect to it. And then storage, okay? But again, it's a framework, so it's flexible to meet the customer use case. So, in closing, so Boston Medical is a new division within Boston. So my call to everyone here is come and meet us, contact us, and Google Boston Bites, okay? So Boston Bites is where we bring various organizations together to talk about technological issues that they're experiencing. So I'd like to do the same in terms of AI and medical healthcare. So my contact details are here. You can get me on Twitter. I'm on LinkedIn. I'm sure these slides will be sent out to everyone as well. So thank you, everyone, for your time. And any questions? Do we have time?
Thanks, that was a really great talk. You gave the example of liver, which is often where disease is spread to, so it's usually metastatic disease. So I wondered, have you applied your technology to more difficult cases like oligomeds? Also, have you looked at cancers where there's a primary cancer where currently we don't do very well, I mean, such as pancreatic?
Yeah, that's a really good question. So the reason that we focused on the liver is because, and again, we're looking at dense organs in general, is that because of the density of the organ, the carcinomas are very difficult to detect. So there's a lot going on these days in terms of breast cancer, in terms of lung cancer. So this is where primarily we've started our study. We are going to develop a roadmap in terms of the way we're going to develop the product and the way we look into it. And again, this is why the partnership is important as well. So that will enable us to aim our research in the right way.
Thank you.
Okay. Yes, sir.
Thank you for the presentation. It was good. So just one thing, everywhere we talk about the data and rules and regulations on that top of it, right? So when we because we are from healthcare background too, but when we try to run any sort of algorithm or try to ingest that healthcare data into the platform, right? Then the hospitals, very adamant to share the data, right? So how do you your platform address those issues, because every area or geography is having different compliance and regulation on the data.
100% yes, yeah, and that's a really important question. So different countries will have different levels of compliance. So there's a process that we need to go through to make sure that we fully comply with any local laws. I would say these days, a lot of organizations will use RDP. So that means they get access to the local network of the healthcare provider. But ultimately, the nirvana is to get to a kind of a more cloud-based, cloud-consumed managed services model. But you're 100% right in the fact that it needs to be secure, and it also needs to adhere to the standards of that location.
Thank you. Thank you.
Have you thought about marrying up the optical detection with things like actual things like full blood count and flow cytometry and immunology?
That's so we're at the, I'd say, early stages of the roadmap. So nothing's off the table. So and again, that's why we're relying on the partnerships to help us direct our route of the way the product's going to develop over time, to make sure it resonates with the most use cases possible. A lot of questions today.
Cheers, Prerogative. You're saying this doesn't replace the clinician?
Absolutely not.
So a very simple question, could it?
At this stage, absolutely not.
So
No.
follow-up question, at what stage could it?
At what stage could it? Yeah, we're advancing, aren't we, technologically? Who can say what state we're going to be in, say, in 1,000 years' time? But as of the moment, it would not replace the clinician at all. No, it's there to help them. It's there to make sure that going from that kind of 90th percentile up to the 99.99 percentile of accuracy in delivering an outcome.
Okay, thanks, Amos. Okay, we'll wrap that session up there. Thank you.